All right, so here's one of my physics books on the quadrant model. So let's go over a few examples. There's a 4-color printing process. There's 4 colors used to print: C, Y, M, and K, cyan, yellow, magenta, and black. Nassim Haramein talked about the 64 tetrahedron grid. This is called the isotropic vector equilibrium. Buckminster Fuller saw the tetrahedron grid as the geometry of space-time. Here we have the standard model of particle physics. It's actually 4 groups of 4. It's a 4x4 matrix, 16 squares. And the pattern is a quadrant pattern where we're going to have these 3 groups of 4 are similar, but this group of 4 is different. And within each of the groups of 4, the 3 are similar, but the 4th is different. Example would be the up quark, the down quark, the electron and electron neutrino. Now, the up quark and down quark, that's a duality. Then we have the electron, which is a doer. And then the electron neutrino can become the previous 3, right? It can transform in the previous 3, and it took a long time for physicists to discover the neutrino. The 4th is always different. Okay, that's one generation of particles. Then the second generation is the charm quark, the strange quark, and the muon and the mu neutrino. Again, it's the same pattern. There's 3. There's the charm quark and strange quark. Those are the duality. The muon is the doer, and then the mu neutrino is a different 4th. Then we have the top quark, bottom quark, tau, and the tau neutrino. Again, that same pattern. So these 3 groups of 4 are called fermions. This group of 4 is called bosons. They're called bosons. And then they have the gluon, the photon, the Z boson, and the W boson. So 3 groups of 4 are similar, and then the 4th group of 4 is different. We have a 3+1 pattern within the 4x4 matrix. Then we have our reality is just made up of 4 particles. So there's 16 particles in all the standard model of particle physics, but this reality that we're living in is only made up of 4 of those particles. And those particles are the up quark, down quark, electron, and electron neutrino. Up quarks and down quarks make up protons and neutrons. So we know about protons, neutrons, and electrons, but it turns out that the protons and neutrons aren't the most fundamental particles. There's up quarks and down quarks which make them up. So the 4 fundamental particles are the up quark, down quark, electron, and electron neutrino. I talk about tetraquarks. Triquarks are seen as normal, but there's this transcendent type of quark called the tetraquarks, which is 4 quarks. That's a 3-4 dynamic, which is the basic conflict in the makeup of the quadrant pattern. It's that dilemma and interplay between the number 3 and number 4. So there are 4 paths in the proton-proton chain. The 4th path is extremely rare. It's different. The final goal of the proton-proton chain is the production of helium-4. Helium-4 looks like a quadrant. 4 protons, or 2 protons and 2 neutrons, making a quadrant. The primary source of energy in the sun is a fusion of the 4 protons into 1 alpha particle. Carl Jung knew about this process and saw it as an example of the quaternity. I looked at a book on that, and Carl Jung was talking about that. Carl Jung again talked a lot about the idea of the quaternity, and he saw the creation of the helium with the fusion in the sun. The helium is made up of 4 particles. The fusion of the 4 particles, and he saw it as an example of quaternity. It's a quadrant. So I watched a crash course. The crash course show is on YouTube. There's a crash course show, And then one of the shows was talking about film. And one thing that they talked about was, one thing the professor talked about was how an important element of the creation of the cameras used in film was the use of the Maltese Cross Geneva drive. And it looks like a quadrant. So tow trucks look like crosses. There are 4 variables in the ohms wheel: watts, current, volts, resistance. Triple star systems are sort of common, but quadruple star systems are more rare. Again, we're seeing that 3-4 dynamic where the 4th is different. Systems beyond 4 stars are exceedingly rare. So the 4th is always different, 5th is always questionable. Kepler-64 is the first known quadruple star system. KOI 2626 is a quadruple star system with an Earth-sized planet. It's the first quadruple system to be found with an Earth-sized planet. Chi Tauri represents a 3+1 pattern. Chi Tauri is a quadruple star system with the 4th orbiting the other 3. The 4 stars orbiting the other 3 every 50 years. Again, we're seeing within that the 4th being different. The 4th star, we're seeing that same pattern. So I learned about the Hertzsprung-Russell diagrams in an introductory to astronomy class that I had at UCSD. And in the Hertzsprung-Russell diagrams, there are 4 groups of stars. This one, this one, this one, and the 4th one, which is different. There's the main sequence, the giants, the supergiants, and then the white dwarfs, which are different. The white dwarfs are made up of carbon, and carbon has 4 valence electrons. It forms a quadrant. Carbon is the most important element in organic chemistry. And it's no coincidence that it's a quadrant. It's called the miracle element. Silicon is also called the miracle element. It's used in computers and everything. And it also has 4 valence electrons and it forms a quadrant. Germanium also has 4 valence electrons and it's used in semiconductors. So the center star of the Big Dipper is Mizar. Mizar is really a quadruple star system. The Penrose diagrams are elemental in black hole physics. I watched a teaching company course on black holes, and a large amount of it was dedicated to the study of these Penrose diagrams. See other quadrants. There are 4 exact black hole solutions to the Einstein field equations, and we're seeing a quadrant formation. So uncharged, non-rotating systems are called Schwarzschild systems. Charged, non-rotating are Reisner, Nordstrom. Charged, rotating is Kerr, and charged, rotating is Kerr-Newman. Oh no, uncharged and rotating is Kerr, and charged and rotating is Kerr-Newman. There are 4 possible bosonic string theories: open and closed, oriented, open and closed, unoriented, closed, oriented, closed, unoriented. Paul Ernstfest, Max Tegmark, Immanuel Kant, John D. Barrow, Hermann Weyl, and many others have argued that the privileged, quote, privileged character of 3+1 space-time. And they've argued for the privileged character of 3+1 space-time. 3+1 space-time is 3 dimensions of space and 1 dimension of time. So we're seeing that this is the privileged spot. If it's 2 dimensions of space and 1 dimension of time, it's too simple. It's not going to work. The existence isn't working with that. If it's 4 and 1, it's unstable. If it's 3 and 2, let's say there's 2 dimensions of space-time or of time, it's unpredictable, ultra hyperbolic. So there seems to be this privileged position of 3+1. That's the quaternity. That's the quadrant. Eric Dollard has a book called The 4 Quadrants of Electricity. A lot of people know about AC and DC currents, but there are 2 more types. They are IC and OC. Okay. continuous currents, alternating currents, impulse currents, and oscillating currents. Dollard's book is called The Quadrant of Electricity. Bearden claims that Maxwell wrote his original equations in quaternions. Quat is 4. Pauli described that he felt that the power of quaternions in physics illustrated the fact that the universe was based around a sort of, as he saw it, magical quaternary logic. Okay, so Pauli, as I described before, he was one of the founders of physics, and he was very interested in Carl Jung's idea of the quaternity because he originally there were 3 quantum numbers, and he discovered that there was actually a 4th quantum number. So he described that his greatest achievement was moving from the number 3 to the number 4. That's that 3-4 interplay within the quadrant model. That number 3, number 4 tension and reconciliation. So here's the 4 Maxwell's equations. It describes all of electromagnetism. Here's the 4 kinematic equations that I learned in physics 1A. These 4 equations can describe all of motion. Here's the 4 terrestrial planets. So there's 4 terrestrial planets, and then there's an asteroid belt, and then there's 4 gas giant planets: Mercury, Venus, Earth, and Mars. Astrology employs the 4 elements. There's 4 quadrants in Vedic astrology. The Patty-Salem model proposes a transcendent 4th color charge to the standard 3. Again, we're seeing the trinity moving to the quaternity: red, green, and blue. And then this new model adds lilac. Originally, there were 3 quantum numbers. Pauli discovered the 4th quantum number. Pauli said his greatest achievement was moving from 3 to 4. Pauli dialogued with Jung. Okay. Principal quantum number, azimuthal quantum number, magnetic quantum number, and then the 4th transcendent one's a spin quantum number. So here's the baryon decuplet. This is used in physics, and it's a tetrakiss formation with 4 rows. Again, the Pythagoreans saw the tetrakiss as the foundation of existence. And according to many people, a lot of people think that Pythagoras knew that the tetrakiss, or saw the tetrakiss and the tetragrammaton as being the same thing. And the tetragrammaton was what the Israelites worshipped. So there's an X-shaped structure at the center of the Milky Way. The X is the cross, the quadrant. The X is the quadrant. I have seen lectures where people relate the X-shaped structure to the cross and see it as evidence of intelligent design of the quadrant. Quadruplanes have 4 stacks of wings. 4 stacked planes are rare. No plane beyond 4 stacks of wings has been successful. George Cayley is considered the father of aviation. He identified the 4 forces of flight. Planes themselves look like quadrants. The German Air Force was called the Luftwaffe. Below is depicted the finger 4 formation used by the Luftwaffe. I don't know how to pronounce that. Luftwaffe. It is a 16 square quadrant model. So we're seeing 4 groups, 4, 4, 4, 16 squares. 16 planes in all, 4 groups. Standard television uses 3 types of pixels. Standard television uses red, blue, and green. Quatrone adds a transcendent 4th pixel, the yellow pixel. So we're seeing again that 3 plus 1. Charles Hubbard Judd said that humans distinguish 4 unique hues. So here's the 4 hues that HUD proposed. Einstein gained notoriety due to his miracle year. Due to his miracle year. During Einstein's miracle year, he wrote 4 papers. The 4 papers are called the Annus Mirabilis papers. The 4 papers are the photoelectric effect, Brownian motion, special relativity, and mass energy equivalence. These are the 4 Galilean moons. So Galileo made a huge discovery when he noticed that planets have moons that orbit them, and the first thing he discovered was these 4 Galilean moons. And it's interesting because originally he discovered 3 of Jupiter's moons, but then later he noticed the 4th. We're seeing that 3 + 1 pattern. Io, Europa, Ganymede, and Callisto. Ptolemy was a renowned ancient astronomer. Ptolemy's best known work is Tetrabiblos. Tetra means 4. Tetrabiblos is divided into 4 parts. I watched a TV show on the solar system. The astrobiologist interviewed on the show said that the most exciting place in the solar system for astrobiology is Enceladus. The reason he said it was so enthralling to astrobiologists is 4 craters discovered found on the moon gush out water. The 4 stripes are known as the tiger stripes of Enceladus. The 4 stripes. There is a phenomena called X-shaped radio galaxies. X's are quadrants. The Michelson-Morley experiment is a preeminent experiment in physics. The experiment was said to disprove the notion of the ether. The shape of the experiment was a quadrant. So here's Michelson-Morley experiment. It's a very famous experiment, and it takes the formation of a quadrant. Here's another diagram of their experiment, making an X. The 4 Bell states are the 4 simplest examples of entanglement. A measure of the value of one qubit will assign the value of another qubit in one of 4 ways. The 4 Bell states are 4 maximally entangled quantum states of 2 bits. In Carl Sagan's book Comet, Sagan reproduces a Chinese Han manuscript that shows a comet tail in the form of a swastika. Sagan hypothesizes that the swastika symbol came from the actual comet that had a swastika tail. It has also been hypothesized that the symbol of the swastika came from bird tracks of birds with 4 toes. The Malaysian fish owl had 4 toes in the shape of a swastika, and it was called a ketu, which in Sanskrit means comet. So he's trying to see a connection between those 2. Guinan hypothesized that the swastika was a polar symbol. Here's the Big Dipper, and here's the swastika. The quadrant theory says that the quadrant is a form of being. The reason the swastika is seen in so many places is it is a form of existence. Here's the Dalai Lama with some swastikas. Swastika is also called the seal of the Buddha's heart. Here's the swastika on the Buddha's heart. The big 4 telephone carriers are T-Mobile, Sprint, Verizon, AT&T. The 4 strokes of a 4-stroke engine are intake, compression, combustion, exhaust. Here's the 4-stroke cycle. The big 4 asteroids make up the vast majority of matter in the asteroid belt. The big 4 asteroids are Ceres, Pallas, Vesta, and Hygeia. So that should be good for now. I'll make another video soon.